Bloom filters. A Bloom filter is a space-efficient data structure that tells you whether an item is probably in a set, using far less memory than storing the items themselves, at the cost of occasional false positives. Every second, your database answers thousands, sometimes millions, of requests. But here's the surprising part: a huge share of those requests are asking for something that doesn't even exist. A username nobody registered, a file that was never uploaded, a cache key that's already expired. What if you could know that before you ever touch the database? That's exactly the problem a Bloom filter solves. Here's how it works. Take an item, say a username, and run it through a handful of hash functions. Each one points to exactly one bit in a big array that starts out full of zeros. Inserting the item just means flipping those specific bits to 1. Notice what's missing. The item itself is never stored anywhere, only the pattern of bits it left behind. To check whether something might exist, you hash it the exact same way and look at those same positions. Bit 7, set. Bit 15, set. Bit 30, set. Every single bit is already on, so the filter's answer is maybe present. That's not a guarantee of anything. It's a signal that says, this one is worth checking further. Now here's the catch. A second item that was never inserted can hash to the exact same 3 bits, purely by coincidence, and the filter will confidently say may be present. That's a false positive. But flip it around, check a third item, and if even one of its bits is still 0, there's no ambiguity at all. It is definitely not present. A Bloom filter can lie about what's there. It never lies about what isn't. The fix is tuning 2 numbers, the size of the bit array, and how many hash functions you use. A small, crowded array collides constantly. Almost every bit ends up set, so almost everything looks like a match. A larger, sparser array barely collides at all. More bits means fewer false positives at the cost of more memory. And it turns out the number of hash functions has its own sweet spot too. Too few, and collisions pile up. Too many, and you fill the array just as fast. This is exactly why Bloom filters show up everywhere performance matters. Cassandra keeps one in front of every SS table on disk so it can skip an expensive scan the instant the answer is definitely not here. Chrome does something almost identical with malicious website addresses, checking a local filter before it ever has to call out to a server. Same trick, same payoff, avoid the expensive check whenever you possibly can. A Bloom filter trades a small, tunable chance of a false positive for a guarantee that matters just as much. When it says no, the answer is always no. That one guarantee, cheap, compact, and never wrong in that direction, is enough to save real systems millions of expensive lookups every single day. If you enjoyed this video, please like it, comment below, subscribe to the channel, and tap the bell icon so you don't miss the next one.